Hello, by the end of today's lesson, you'll be able to solve a system of equations using a graph. We are on page 227 in your textbook. That would be lesson 1.8, solving systems of linear equations by graphing. So let's take a look at the first example. It says graph the pair of equations together, and they give you two equations, y equals 3x minus 2 and y equals negative 2x plus 3. Let's talk about these two equations first. You can tell that there's going to be one solution. We know there's going to be one solution because the slopes, the m values or the coefficient on x, are different for both of the equation. One has a slope of 3 and the other one has a slope of negative 2. We also see that they cross the y-axis at different points. The first equation crosses the x-axis at negative 2, and the other equation crosses at positive 3. So in your book, there's a coordinate plane already there, but I'm going to draw a coordinate plane here so that we can graph this example. So here we have a coordinate plane and the two equations that we want to graph. So to graph these, I always look at the y-intercepts first. So let's graph the first one. It's negative 2. So I come down to negative 2 and put my point. Now we have a slope of 3. Remember, rise over run is the slope. So that's 3 over 1. So we're going to go rise 3, 1, 2, 3, and run 1, 1. So our next point is going to be right there. Then rise 3, 1, 2, 3, run 1. 1, 2, 3, 1. I'm going to do my best to draw a line through those points. And now let's go ahead and look at the second one. I'm going to use a different color marker. I don't know if it'll show up. But let's go ahead and graph this equation now. It crosses the y-axis at positive 3. So 1, 2, 3, it's going to cross right here. Kind of shows up a different color. Now our slope is negative, so we should imagine and remember what it's going to look like. It's going to have this type of a slope, and it's a negative 2. So rise over run, that means it's going to go down 2 and over 1. So from this point, I need to go down to negative 2 and over 1. Down 2 and over 1. You already see where they So you can see where those two lines cross right here at point 1, 1. So the solution for this system of equations is this point right here, 1, 1. So let's review what this means. This means that for both of these equations, the point 1, 1 works for both of these. Now we can double check this by solving this using substitution. Now because these are both solved for y, when I plug this one in for y, it makes it very, very easy. I'm going to do that down here. So instead of writing y, I'm going to write what the second value, or what the second equation is solved for y. So negative 2x plus 3 equals 3x minus 2. So I always like to move the x that has the least coefficient. So in this case, negative 2 is less than 3. So to get all x's on the same side of the equation, I'm going to add 2x to both sides. Now, negative 2x plus 2x is 0, so I'm just left with 3 on this side. And 3x plus 2x is 5x. Don't forget this negative 2, or minus 2. Now, to isolate x, I'm going to add 2 to both sides to get rid of this. Because remember, whatever we do to one side, we have to do the other. So this equals 0, so we're left with 5x over here, and 3 plus 2 is 5. Once again, to isolate x, it's being multiplied by 5, so I'm going to divide both sides by 5, and we get x equals 1. Now remember, this is just the first x value. So now I need to go and find what the y value is. And to do this, I simply take this x and I put it back into one of my equations. I'm going to choose this one because it doesn't have a negative coefficient. So in here, if I put 1 in for x, so 3 times 1 is 3, minus 2 is 1. So we know this is the correct answer. If you turn the page to 228, it once again gives you the definition of a system of equations. So at the top it says a system of equations is a set of equations that have the same variables. An ordered pair is a solution of a system of equations. What that's reminding you is that you always need to give your answer as an ordered pair. Now, you can solve a system of equations by graphing it or by using substitution. So let's go ahead and do the equations on page 229. First, for number 3, graph both of those equations on the coordinate plane they give you. Then, when it says check your answer, I would like you to use substitution to solve for x and then for your y value by plugging in your x back into the equation. You can check your answers to the Your Turn on page 229, numbers 3 and 4, in the back of your book. If you get those correct, those ordered pair and your graphs look like those two graphs, then move on to Delta Math today and complete your exit ticket. Thank you.